Question 16. There are only red counters, blue counters and purple counters in a bag. The ratio of the number of red counters to the number of blue counters is 3 to 17. Sam takes at random a counter from the bag. The probability that the counter is purple is 0.2. Work out the probability that Sam takes a red counter. So lots of reds and blues and purples. The best way to approach this is to write down the information you've got. So I know I've got red counters, blue counters, and purple counters. The ratio of red to the ratio of blue is 3 to 17. So these are in the ratio 3 to 17, and I don't have the purple ratio. So I'll just put a question mark for that one. Sam takes at random a counter from the bag. The probability that the counter is purple, so this probability is 0.2. Work out the probability that Sam takes a red counter. So I want to know the probability of taking this one. There's a few different ways of approaching this, but this question is testing initially that you know that probabilities have to add up to 1. So if there's a 0.2 chance of getting a purple, there must be a 0.8 chance of getting a red or a blue. The red and the blue come to 20 counters. So I know that these 20 counters represent 0.8 of the probability of this event happening. So what I actually want is 3/20ths of, which is a way of saying multiply, 0.8. This process here of writing the sum actually picks you up 2 marks very quickly. Just to take a moment to go over that again, this part of the counters, the red and the blue, has a probability of 0.8 of appearing, and 3 out of 20 of the counters are red. So I want 3/20ths of 0.8 to get my probability that I pick a red. Don't forget any whole number has a 1 on the bottom, so when you multiply, I'm doing 3 times 0.8, which is 2.4. 20 times 1 is 20. Obviously this isn't much of a probability here, but 2.4 divided by 2 will be 1.2 over 10, and 1.2 divided by 10 is 0.12, and that is a probability of getting a red counter. And there's my third mark.